Collecting a vampire bat's feces is not an easy task. You must go into the jungle, to the cave where the bats live, then lurk at the entrance at dawn or dusk. As the bats come winging in or out, you catch them in nets spread across the cave mouth and transfer them to a cloth bag. Then, you wait. Sometimes, says M. Lysandra Zapata Mendoza, who works in bioinformatics and is an author of a recent paper drawing on this raw material, you don't get what you need. They get shy, she says, and one has to let them go before they release a sample. Luckily, however, Dr. Mendoza's colleagues at the bat cave mouth were able to collect enough feces that she and other collaborators could sequence the DNA of the bacteria within it. By combining an understanding of what lives in a vampire bat's gut with the flying mammal's genome sequence, they have revealed tantalizing insights into how the blood-supping creatures manage to survive on such an unusual food. Blood, it turns out, is a very difficult thing to live well on. There are almost no carbohydrates. It's nearly all protein and few vitamins. Even worse, it's often laced with viruses. Still, beyond mosquitoes and other insect bloodsuckers we're more familiar with, a handful of other organisms have somehow managed to do it. As blood-eating mammals, vampire bats, which live in the forests of Mexico and Central and South America, are particularly intriguing. For the study, which was published Monday in Nature Ecology and Evolution, Dr. Mendoza and colleagues compared their vampire bat genome and microbiome with those of 3 other bat species, a bat that eats fruit, one that eats insects and one that eats mice, lizards, and other small animals. They saw certain patterns, linked with generating greater diversity for natural selection to work on, clustered in parts of the vampire bat genome related to the immune system and metabolism, which could be related to the special challenges of their diet. They were also surprised to find that the vampire bat genome was not riddled with pieces of viral DNA, as many viruses will insert themselves into their host's genetic material. But they did find genes involved in fighting off such viral invasions in the bat. That suggests that the creatures have adapted to dodge the onslaught of pathogens they likely encounter in their food. Vampire bats had the same general groups of bacteria in their guts as other bats. But when the researchers looked at what the microbes were making and doing, they found big differences. In vampire bats, the microbes looked to be focusing on metabolic tasks like breaking down proteins and producing vitamins that the bats might otherwise lack. That suggests that only by looking at the microbiome and the genome together is it possible to understand how animals with odd diets have made it work. Dr. Mendoza, who performed the work as a researcher at the University of Copenhagen, will no longer be studying bats. But she hopes other researchers might take up some of the still unanswered questions about vampire bats and their tiny inhabitants. For instance, as vampire bat babies start to be weaned from their mother's milk, the mothers will regurgitate blood for them. I believe this helps to prime their gut microbiome for when they are ready to go out for hunting, said Dr. Mendoza. Perhaps that seeds the babies with bacteria that will allow them to thrive on blood, or signals to the bacteria they already have to change modes. She wished she had been able to look at samples of this regurgitated blood. Getting their fecal samples was already hard enough, she said. I'll just leave that idea for someone else to explore.